We are going to use trigonometric substitution to evaluate the integral here. So let's look at the table here to compare and find what is the suitable substitution to solve this integration. If you look at the first one, if the integrand contains a squared subtract x squared, we will let x equals to a sine theta. We found that it's actually quite similar with this one. Let's compare. So if x squared subtract x squared is the integrand, x equals to a sine theta will be the substitution. So let's compare 16 subtract 4x squared. If you look at this 16, we can actually rewrite it as the term of perfect square, which is 4 squared. And 4x squared is actually 2x squared. So if we use the same method, you will observe that here, instead of writing x, we will write 2x. And then our a is actually 4 sine theta. So if we divide both sides by 2, so we have x equals to 4 divided by 2, so we have 2 sine theta. So this is the suitable substitution that we are going to use later for this question. So let's close this table. So we will start to substitute. Before that, if we have x equals to 2 sine theta, we need to differentiate x respect to theta because later we need to use it for substitution. So if we differentiate x respect to theta, we have 2 cos theta So we are going to substitute x equals to 2 sine theta into the formula and into the integration, and then the dx, actually we have to change it in the terms of d theta. 16 subtract 4, so our x now is 2 sine theta. So we have 2 sine theta squared dx. So if dx divided by d theta equals to 2 cos theta, so our dx is actually 2 cos theta multiply d theta if we use a cross multiplication. So we continue. If we square this, simplify, we will get 16 sine square theta 2 cos theta d theta. We can actually factorize the 16. So we have 16, 1 subtract sine square theta 2 cos theta d theta. So square root of 16 is actually 4, so we can bring out the 4. So what we left here in the square root is 1 subtract sine square theta. We know that 1 subtract sine square theta is actually cos square theta. So if we take the square root of cos square theta, we get cos. So cos and multiply with another cos, we have cos square theta. So 4 multiply 2, we get 8, so we just lay it outside here, d theta. So from here, actually we need to use the trigonometric integral. So we know the formula of cos 2 theta. So we rearrange it and substitute so that we have everything in the terms of single terms so that we don't have the power. So we change cos square theta to 1 plus cos 2 theta d theta. Actually, how we get this part? We know that double angle for cos 2 theta is 2 cos square subtract 1. So if we need to find cos square theta, so we rearrange it, cos 2 theta plus 1 equals to 2 cos square theta. So we divide by 2 both sides. So we get cos 2 theta plus 1 divided by 2. So this one, if just now we substitute it in here, So it means that 8 multiplied with cos 2 theta plus 1 divided by 2. So 2 and the 8 cancel off. So we have 4 here. So what we left here in the integral is 1 plus cos 2 theta d theta. So now we can continue to perform the integration as usual. When we integrate 1, we have theta. When we integrate cos, we have sine 2 theta divided by differentiation of inside function 2 theta, we get 2. When we perform integration, we have to divide by 2, and then plus a c. So we simplify it, we multiply it in. So we have 4 theta plus 2 sine 2 theta plus a c. Well, can you leave the answer like this? We have to give back everything in the terms of x. So we know that double angle for sine is actually 2 sine theta cos theta plus c. So if we arrange it, we have 4 theta plus 4 sine theta cos theta plus c. So now we need to produce a triangle so that we can express all the theta terms in x. So from beginning, we have x equals to 2 sine theta. X equals to 2 sine theta. In other words, sine theta equals to x divided by 2. So if we produce a right hand triangle, so sine theta, let's say theta is here. Sine theta equals to opposite divided by hypotenuse. Opposite is x, hypotenuse is 2. So what we have for adjacent will be 2 square subtract x square, and then we have the square root. So we have 4 subtract x square. So if we need cos theta, it's adjacent divided by hypotenuse. So we have 4 subtract x square divided by 2. So we have sine theta here, cos theta here. Later we can substitute. How about theta? So just now we have sine theta equals to x divided by 2. So theta will be inverse of sine x divided by 2. So we'll substitute all this into the final answer. So we have theta, we need to substitute this. Substitute the sine, substitute the cos. So our theta is inverse sine x divided by 2 plus 4. Our sine theta is x divided by 2. Our cos theta is square root of 4 subtract x square divided by 2. Then plus c, we simplify if possible. 4 and these 2, we just cancel it off. So we end up with 4 inverse sine of x divided by 2 plus x multiplied with square root of 4 subtract x squared plus c. So since this one's cancel off, so we just erase. So this is our final answer to evaluate this integral by using trigonometric substitution.